In this video, we're going to evaluate the integral of the quantity sine of x plus cosine of x divided by the square root of sine of 2x with respect to x. Here's the integral we're going to solve. Let's first express sine of 2x in terms of sine x and cosine x. Remember the double angle formula for sine. Sine of 2x is equal to 2 sine x cosine x. So we can rewrite sine of 2x as 2 sine x cosine x. Our next step is to find the appropriate substitution to simplify the integral. Let's set u equal to sine of x plus cosine of x. Now, we need to find the differential due to adjust the integral. By differentiating u with respect to x, we find that due equals cosine of x minus sine of x. So we have due equals cosine of x minus sine of x times dx. Looking at our substitution, we can express due in terms of dx. Since we have sine of x plus cosine of x, it can be split to express our dx more clearly. Let's solve for dx to rewrite the differential parts nicely. Notice this is looking more manageable for us. Let's substitute u and due into the integral. In terms of u, we've switched the equation to the integral of u over the square root of 2 times sine of x times cosine of x times due over cosine of x minus sine of x. Now, recall u is defined as sine of x plus cosine of x. Rearrange the terms in the square root part and evaluate the integral. The expression reduces to contain cosine of x chance a cosine, and sine cancel out, which simplifies further our equation. This integral can now be solved by easily evaluating the remaining terms as they result in constant integration. For simplicity, factor out constant values. In this case, the integral simplifies to contain a natural log relation to our function at x due to the square root calculations. Finally, back substitute the original variable by using the substitution u equals sine of x plus cosine of x, restore our back to its true form, and evaluate the expression. As a result, this leads to an expression evaluating to a factor of the natural log of sine of x plus cosine of x plus the square root of sine squared x plus cosine squared x minus 2. From this, we've completed the evaluation of our integral, while ensuring to include the constant of integration. This concludes the lesson. Thank you for watching. From this, we've completed the evaluation of our integral.